Okay, so look, our definition of mod x, right? The very definition of mod x is a fallback. You always have that to begin with. If you don't know where should I begin from, doesn't matter. I see there are some absolute value signs and I just don't know what to do about it, how to handle it, doesn't matter at all. Just I am going to use the definition of absolute values and I'm going to write that down over here. I said mod x is equal to x if x is greater than equal to 0 and it is equal to minus x if x is less than 0. All right. So now, I have two absolute values, x and y. And then when I want to remove their signs, I'll have to take cases. So I'll have to take two cases over here where this is positive and where this is negative. And I'll have to take two cases over here also because this is also after all absolute values, right? So then what happens then? I have case 1 where I say that, okay, x plus y less than equal to 4. Which is this case 1? This is, I have assumed this case 1 is that x is greater than equal to 0 and y is greater than equal to 0, right? Then I can write, when I assume this precondition, these preconditions, I can write this entire thing as this. And this is okay. This is something that I can manage, right? This is the equation of a line. This is something I can manage, okay? Then I have my case 2. What is my case 2? It is minus x plus y is less than equal to 4. And how did I get this? I said because x can be negative also and I have to take that case as well. So when x is negative but y is positive or 0, then this is what I get. Then instead of the mod x, I write minus x, and then instead of mod y, I'll just write y. Again, this is also the equation of a line. I can handle it, no worries. Case 3, where this is negative, y is negative, but x is positive. So I say x minus y is less than equal to 4. So this, my x is positive and my y is negative. Is that okay? Right? Now my x is positive and my y is negative. Again, case 4. This is my last case where x is also negative, y is also negative. This is my x is less than 0 and y is less than 0. Always remember, these are my preconditions. I should not forget them, right? I have to keep them in mind. Okay, how many ordered pairs are there such that x, y are integers and they satisfy this? Yeah. Now these are the four inequalities that I have got, right? All right, fine. Can I draw them? I have x plus y is less than equal to 4. Forget the less than for the time being. I know how to draw. X plus y is equal to 4. How do I represent this? Y is equal to minus x plus 4, right? That is a line. Y is equal to minus x. So it has a negative slope, right? So this is what it is going to look like, right? If I draw it, it will look like this. But plus 4, I mean, this is equal to y is equal to minus x plus 4. So y is equal to minus x is over here. But it is plus 4. So then over here, right? So it is moved up by 4 units. So this is what the line is going to look like. Yeah. So I have a 4 over here and of course I have a 4 over here. Make sense? There was this particular line over here which was y is equal to minus x and that moved up by 4 units. We just discussed how when I add something to it, then the graph moves up, right? So here the line has moved up. Okay. Now, but it is actually less than equal to 4. This is y plus x is equal to 4. Less than, how will I find that? I'll just check for this point, right? 0, 0. If I put 0, 0 over here, x plus y is less than equal to 4. If I put x0 and y0, I get that 0 is less than 4. It is valid, which means that this point is valid, right? We've discussed this as well, right? That How do I graph an inequality? I first draw the equation and then I see whether this region works or that region works. And how do I do that? I just take any point and then I check for that particular point. And of course, the easiest point to check for is 0, 0. So when I put 0 here and 0 here, what do I get? I get 0 is less than equal to 4, which is valid because 0 is less than 4. So that means this entire region is valid, right? The entire region on this side of the line, below the line is valid. So if I make too much of it, then it's just going to become very messy. So I'm not going to do that. But we know that this side, the 0, 0 side is valid. And that this represents this entire area, this represents this particular inequality. Okay, look at this one now. Minus x plus y is less than equal to 4. So essentially, this is nothing but y is less than equal to x plus 4. So, whenever I have to draw, I'll say y is equal to x is this. This is my reference. That's the easiest thing to start with. I say y is equal to x is going to be over here. But this is plus 4, which means that this particular line has moved up 4 units and it has become this particular line. Right? So now, of course, over here, this is going to be minus 4. We know that the slopes of these lines are all 1, right? So then this is going to be minus 4. Okay, let me check. If I put 0, 0, what happens? I've put 0 here, I've put 0 here. I get 0 is less than equal to 4. Again, this is valid, which means that, this entire area on this side of the line is valid, right? It represents this particular case. So this line along with this entire area, that represents this case. Okay, look at this one. This is equal to what? This is y, if I'm taking this over there, and is greater than equal to x minus 4. Makes sense? I've just rearranged it, right? I've taken y over there. It becomes greater than equal to 4 over there, so x minus 4. Why? Because, I know how to draw y is equal to mx plus c. It's the easiest for me to think in terms of y is equal to mx plus c because I start from y equal to x and then give it the slope and then add c, and then it's very easy for me to draw the line. So I'll always try to bring it in that form. Okay, so if it were y is equal to x minus 4, so y is equal to x, again, that is this particular line. Y is equal to x, yeah, positive slope. Minus 4, it has gone down by 4 units. So then this particular line is actually going to look like this. Yeah, and if I put 0, 0 over here, I get 0 greater than minus 4. I've put 0 here and I've put 0 here. I get 0 is greater than equal to minus 4, which is valid, which means 0, 0 point is again a part of this inequality of ours. So then this entire region above this particular line is again valid, right? And then when I draw this one, of course, I'm sure you would have guessed now that this line is going to be this particular line. And of course, then this region is going to be valid. So then, the 4 lines, they actually cover this entire region. They, this region is bounded by these 4 particular lines. Yeah. So then how many ordered pairs are there such that x, y integer and they satisfy this inequality? What can I say? I can say that all the points where x, y are integer, in fact, all the points in any case, they satisfy this particular inequality, right? The points lying on these particular lines, these lines, okay, let me show you. No. Okay, red. So the points lying on these lines, on this line, on this line, and the points lying inside, in the inside area. Okay? They all are going to satisfy this particular inequality, right? Now, how many such points are there? That is the question. Look, this is 4 over here. This is your 1. Of course, this is 0, 0. This is your 2. This is your 3. And first of all, 1 over here, then this is going to be your 3. This is going to be 2. This is going to be 1, right? And similarly, over here, this is going to be, again, -3. This is going to be -2. This is going to be -1, right? All right. So then all the points that are lying on these lines, they certainly satisfy. And all the points that are lying inside, they certainly satisfy. If I were to be asked that, how many ordered pairs are there such that x, y are integers and they satisfy mod x plus mod y is equal to 4, for example. If I were asked mod x plus mod y is equal to 4, then these are the lines that satisfy, right? Equal to 4. Then I would say, look, there is 1 point here, integer, both x and y are integer, x and y are integer, x and y are integer. So I have 4. Of course, then again here, because they're exactly the same, right? We see a pattern over here. They're symmetrical figures. The figures are absolutely symmetrical. So they're going to be 4 over here also. Then, I'll start with this and there'll be 4 over here also till here. And then I'll start with this and they're going to be 4 over here also. So then overall, I'll have 4 here. Then, I'm including this here. So I have 4 here. Then I have 4 here. Then I have 4 here, and then I have 4 here. So I've included all the points over here. So I get how many points? I get 16 of these points, right? Now, this was in case it was equal to 4. Now, what about inside? How many points are inside? All right. So I know this is 0. I know there is a 1 here. I know there is a 2 here. And I know there is a 3 here, right? I have a 1, a 2, and a 3 over here. So, and this is of course my point 3. So I have a point here, I have a point here, and I have a point here, and these are my integer points. Do we understand? This inside, and then of course this, these are my integer points. Of course, this, these are also my integer points. So, again, I have to look for a pattern, right? I have to look for something that is going to help me, let's say, multiply by 4, because it's a symmetrical figure. I don't want to count everything. If I say 1, 2, 3, 4, 5, 6, and then 7, 8, 9, there's a possibility that I make a mistake. So I don't want to do that. So I say, okay, so in my first quadrant, I'm going to count these particular 6 points. Then I'll similarly have 6 points in my second quadrant where I include these 3 points as well, right? Then I'll have similarly 6 points in my third quadrant where I include these points and I include these points on the axis as well. And then it will be my fourth quadrant over here where I include these points on the axis and then these points which are inside. So 6, 6, 6, and 6. So I get 6 into 4, that is equal to 24 points lying over here. And in all these, I have not included this central point. So I'll include another 1 over here. So I have 25 of these points and 16 of these points. I have a total of 41 points. How many ordered pairs are there? Such that x, y are integers and they satisfy this particular entire thing. There are 41 such ordered pairs, right? Ordered pairs is nothing but, for example, a 0, 0 is a point that is satisfying. Then 1, 0 is a point that is satisfying, right? Then 2, 0, then 3, 0, then here, this is 1, 1, then 1, 2. All these points, including these points, they're all satisfying this particular inequality. So my answer over here is going to be 41. Of course, the question could be anything. For example, what is the area bound by the normally, since we don't have geometry, we not necessary that we get area, but by the way, area of a rectangle or a square or a circle, you should know. Area of a triangle also you should know, because they're considered very, very basic things, right? So those things you should know, because you could get a question which is not exactly, which is not a geometry question. For example, this is more related to algebra, right? But it has some small aspects, some very basic aspects of geometry that is certainly possible. So then those things you should know. So in case, yeah, so in case we had to find the area of this particular, the area bound by the graph, right? So what are we looking for? We are looking for this entire area bound by this graph. So I know that I have 4 over here. I know I have 4 over here. I know I have 4 over here. How can I find the area? Lots of different ways of doing that, right? One, I know that this is nothing but a square. I can see that this is a square. If this is 4 and if this is 4, then of course by Pythagorean theorem, this is 4 root 2. Yeah. So then I can find the area of the square is 4 root 2 into 4 root 2. Or I can also find the area of this particular triangle, half into 4 into 4, and then multiply that by 4. So of course there are lots of ways of doing that. Yeah. Yeah, or half into product of the diagonals, that is also possible. So doesn't matter, whatever you wish to use. But again, yeah, since it's a square, so I mean, square, rectangle, circle, triangle, yeah, those are things that you should know the area of. Yeah. So, any doubts over here? I'm glad. Yeah. So, once, yeah, we get into it, once we understand it really well, then it does seem to be much easier. It does seem to make a lot of sense then. Yeah. Otherwise, you might feel that, okay, this is just way too complicated, but not really.